My name is Harish. I'll be talking about Impala real-time query engine. This is for CSIE E63 Big Data Analytics project. So the agenda is actually what's Impala real-time query, the key features of Cloudera Impala, and Impala and Dermal comparison. Dermal is a Google proprietary. Comparison between Impala and Hive, both are Hadoop components. Architectural overview, Impala and traditional database, when the comparison between the real-time old school RDBMSs. Installation of Cloudera Impala in Amazon AWS using AWS AMIs. Demonstration of queries, conclusion and references. So what's Impala? This is a technology for Hadoop users. Technical vision for bringing real-time and on ad hoc capability to Apache Hadoop, complementing the traditional MapReduce batch processing. It's an open source. It's a reliable data warehouse to execute tasks in data analytics, monitoring, and BI. So it's a performance interactive analytics. It does a performance interactive analytics on unstructured data. It also has the ability to perform real-time on stored on Hadoop via SQL and BI tools through ODBC, JDBC connectivity. Today, Hadoop has a lot of data. Practically, it doesn't make sense to move all those big data to your local. Instead, actually, it's easy to bring a high-speed engine which can query these data. So running Impala on the same cluster as your MapReduce workflows, Hive, big nodes, all this can be run in on the same cluster. So why Impala real-time query? It's a massive parallel processing query engine that runs natively on Apache Hadoop. Impala is integrated with Hadoop ecosystem. It's a part of Hadoop family. It leverages same flexible file format, data format, metadata, security, and other resource framework that MapReduce uses. MapReduce, Apache Hive, Pig, and other components of Hadoop uses. So you need to know that traditional data warehouses doesn't have a real-time access. If you remember how ETL, like Informatica data stage work, is actually all they do is actually they pull from the source system and keep it in a staging area that you call it as data warehouse, and then push it to analytics or whatever BI tools that you are trying to display the results at. So here the staging area is not there. That means actually you have the data real time accessing the source directly, which in this case actually is stored in HDFS or HBase. So if you look at the diagram, actually it's a what it means is actually it's familiar, which supports Hive SQL and Impala SQL. Actually it's a fast, which means actually Impala is faster than Hive or any other comparative engines. It's flexible. Supports multiple storage engines like HBase, HDFS. It's integrated with existing drivers like ODBC, JDBC, all BI tools. Actually, it's an open source. It's easy to use. So the key features of Impala is actually it's a distributed. It's distributed on HDFS nodes, HBase. It's tightly integrated with Hadoop, as I said before. It's written in C++. It has a runtime code generation for big loops. That means massive data can be stored on the memory. It's deployed on Hadoop HDFS clusters, supports wide variety of file formats. Whatever the Hadoop supports, it also supports. It's an in-memory distributed SQL engine. It doesn't have a MapReduce. It has a native massive parallel processing engine. It leverages metadata which is stored in Postgres or MySQL databases. It connects through ODBC, JDBC. It's an open source. It has a very high performance query performance. With no delays of ETL. Actually, ETL you have a delay of transforming into your staging area, but here you don't have a delay. and all hardware used for Impala queries can be used by MapReduce as well. It's a Impala is a well administrated through Cloudera Manager, which is a part of Hadoop ecosystem. So now, where did it origin from actually? That's a comparison that I'm going to talk about now. So Impala and Dermal both are Dermal is a Google proprietary, Impala is open source. If you look at the Dermal 2010 paper, actually it could only handle a single table query. Impala supports a full set join operator and makes SQL so popular. And Impala supports wide range of file format when you compare with Dermal, and it lets the users to run the existing data without having load or transform. Dermal achieves interactive response time over very large data set when you compare with Impala, like a distributed scalable algorithms which allows result set of a query to be computed with thousands of machines in parallel. So that's the difference between Impala and Dermal. Now, Impala versus Hive, both belong to Hadoop family. Hive works on MapReduce, and Impala does not use MapReduce. Hive has a high latency, low through output on queries, but Impala has a low latency. When you compare actually how much faster is Hive versus Impala, it all depends upon hardware configuration. How complex the queries are, availability of main memory as a cache. This all together put together, actually there is a difference of at least 3 to 90 times faster. Impala is faster. The major Impala goal is to make SQL on Hadoop faster and efficient. Impala and Hive uses the same metastore, which means actually which is in MySQL or PostgreSQL. That means actually whatever data table you create in Impala can be accessed in Hive, vice versa. And both supports data types and file formats. So how is it different from a traditional SQL? So when I meant traditional SQL, sir, it's like a Oracle SQL, PL/SQL, or Microsoft SQL. So the same metadata and file are shared with other components of Hadoop ecosystem. You can construct Impala table, definition, and data files in some other environment, and you can attach it to the Impala so that it can run real-time queries. What it means is actually you don't need to have the data residing in your local where Impala is sitting, Impala is installed. All you need is actually the references of where the table is located, where the data can be fetched. It could be of any format. All you need is actually you should have a network path permission to access the data. That's it. So for those currently using RDBMS, Impala SQL is a little bit different actually, TML is data manipulation language. There is no update or delete. That means you cannot do an update or delete. We can use a drop table. That means actually you can completely drop a table or an alter table or a replace. Replace can be done by insert override statement. There is no command like insert into table name ABC values 1, 2, 3. No, that doesn't exist. All you have is Impala. Impala doesn't work like a traditional SQL. Data load can be done by insert statement, which typically inserts a query in bulk by fetching from other sources. There are two variations: insert into, which appends the existing data; insert override, like truncate, followed by an insert. Okay, so Impala architecture. If you look at the picture, Impala architecture, it has a SQL, BVAX, or ODBC connectivity or client query actually, which can connect through to the Impala. And you have a Hive metastore, HDFS name node, actually Impala state store. And everything is executed, monitored by query planner, query coordinator, query execution engine actually, which is again connected with the HDFS where the data is stored, HDFS or HBase. So technically it works actually whenever you send a query actually to the query coordinator. It coordinates a distribution between the nodes. These are individual nodes where the data is getting distributed. So Impala runs on Impad runs on every node actually and handles client request, handles query planning execution. But state stored provides a name service, metadata distribution actually, and use for finding data, etc. How I proceeded with this project is actually I created a VMs using Cloudera Manager that is in Amazon Web Server. So I created a couple of EC2 instances actually. There was two options given in Cloudera documentation. I chose the option A, which is installation of Cloudera, automated installation of Cloudera. You have to choose either Ubuntu or CentOS or like Amazon Linux actually is also sometimes supported. You make sure actually you choose the same region where you are in right now. Then you open up the port 7180, 7183 and HTTP port and ICMP port for communicating. That's under security, and that's under security. Then once you click start installation, actually it is a 10 or 20 step process actually. Before that you need to connect using SSH actually with your key, which is a PEM key which you have to download while creating your AWS account. All you need is actually you just need to choose the instance, what AMI instance what you need, and then here in this case I choose a large instance and I started installing all the, it gives a list of installation what you need and what the version that needs to be installed. So you can choose, pick and choose actually. So here in my case actually I choose the custom services and I chose Impala. I tried many times with different installation set actually. Most of them didn't work actually because of the wrong EMI, some weird reason actually it gives. So here I choose bare minimal like HDFS, HBase, Hive, Impala, MapReduce. So once you choose actually, then the next step is the installation process. It try to install everything actually one after another actually. Many times I got error towards the end, then I had to roll back and I had to redo, and sometimes I have to change the whole process again, whole AMI again actually. So this is a trial and error method actually, wherein you could be or could not be successful. Once you install everything is successful actually, then it gives a nice view actually, where you can click on this configuration and fix those configuration issue actually. And this is the Impala. When you click on Impala actually it will give all the configuration, other things actually that is listed here. So what I did was I took a database of bookstore and which is available in AWS, Amazon Web Server, and then I extracted that into a local database. It's a 1 GB data, 1 to 2 GB of data set actually for each of these three tables. From there I ran for each individual I ran queries for on all those three tables actually by using joins and aggregation and stuff actually. And then I found out that actually the Impala is always faster than Hive. If you compare here actually, if you look at this actually, one query I ran actually ran 6.25 seconds, whereas in Hive using MapReduce it took 140 seconds actually. So the conclusion is actually, before conclusion, limitations are there are a lot of limitation that MapReduce have actually, like a data functionality that MapReduce have is data deletion, full text search and other things actually. Conclusion is actually, for the test queries executed, Impala always provide a high query performance and retains a secure experience in real time. Impala and Hive fetch both shared at the same node of HDFS. That means you don't need to really recreate the data actually. When compared to the traditional data warehouse, data load happens within split seconds, and then results that are produced without moving the data into the existing location. That means you don't need to have the local data sitting locally, which you may refer to as real-time SQL experience. Impala is a good SQL ETL data warehouse engine for analytics reporting. With this Impala pulling the data in real time will have an impact the way the ETL happens in a traditional environment. These are the references, and that's it. Thank you.